Alright class, today we're doing the intermediate value theorem, but before we do that we're actually going to just do an example from yesterday to, what was I going to say? So we can just practice what we learned. So it says example 1, algebraically find the real solutions to this polynomial. Again, we can use our graphing calculator to find two real zeros, and then we can synthetically divide to find the rest. So right here, I already have it typed in. But if you look at your calculator, you see something like this. And to me, it looks like two of the real zeros are -2 and -1. So I'm going to use those two. Okay? So I'm going to say the zeros are -2 and -1. So I'm going to use -2 first, synthetically divide. Remember, you bring the 1 down first, multiply it to the -2, you get -2 plus 1, which is -1. You times -2 is +2. Then you get a -1 times -2 is +2. You get a 1 times -2 is -2, which gives you the 0, which is good. We knew it was a 0. You should get a 0. I'm just going to keep going. Use the -1 now. And then when you do that, you also get a 0. So we know two of the zeros are these. And then if I factor this, this turns into, we divided by this factor and this factor. That's where those zeros came from. We're left with this. If you factor that, you should notice that you get x minus 1 and x minus 1. So really, there are three zeros, but one of them has a multiplicity of 2. The last 0, we also have a 0 that is at 1, and it has a multiplicity of 2. Because that happens. So really, to write this correctly, really you should write it like this. Either way though, but... So that's the factored form. So we have -2 and -1 have a multiplicity of 1 because they crossed. And then 1 at 1, x of 1, you get a multiplicity of 2, which makes sense when you look at the graph because it did bounce at 1. So that should have been a 0 twice. So again, that was just kind of a review. Today we're talking about the intermediate value theorem. Basically what this is saying is, if you have a line that is connected, so it's continuous, like it doesn't have any breaks or anything, which all of these polynomials are always continuous. Okay, so we're saying that we're going to give you a continuous function. If your x values go from, a smaller number to a bigger number, and your y values change signs, then you have to assume that the graph crossed 0 between those two x values. That's basically what it's saying there. So let's look at that in practice. I want to show that between -1 and 0 for x, this graph crosses the x-axis. And the easiest way to do that is to show, well, what's the value when f of the function when you have -1? So you plug -1 in, and you get -6. So on the graph, you have the point -1, -6. Then at 0, you plug in a 0, you get 2. Hopefully you notice that the graph goes from -1, -6 to 0, 2. So that means if this thing is connected, somewhere in between -1 and 0, the graph had to have crossed the x-axis, and we just proved that. So we would say, since y values change, because this was negative, this was positive, change signs, there we crossed the x-axis between x equals -1 and x equals 0. This only works for continuous functions, but that's all we're going to be dealing with, so that is an assumed thing for these problems today. Now we do the same thing here. We have to show that the graph crosses between -3. So you just plug in -3 and see what the y value was. So when you do all that math, you get a big negative number. You get negative 42. And then when we go up to negative 2, when we move over to negative 2 for the x, we get a value of 5. So again, we have the points negative 3, negative 42, and then negative 2, 5. In order to connect those dots, we had to cross the x-axis. So these changed signs. So since the y values changed signs, there's a 0, we cross the x-axis between x equals negative 3 and x equals negative 2. So this one, I would say, let's just look at a graph for example 3. Between which two consecutive integers does the graph have a 0? So let's graph this and see. So I have 3, I should probably clear this whole thing out, 3x cubed plus 4x squared, forgot my plus, minus 8x, and then we got the minus 1. And I forgot my minus. There we go. Alright, so let's take a look at this graph. Okay, so if you look at this, the first time it crosses the axis is between, there's negative 1, negative 2, and negative 3. So between negative 3 and negative 2. So we would say between x equals negative 3 and x equals negative 2. But we're not done yet, because it actually crosses 3 times. So the next time it crosses, it looks like it crosses right before the 0. Which you can check, because you were negative here at 0, but then at 1, if you look at your table, actually it's probably easier to look at the table. When do the y values switch signs? Between negative 3 and negative 2, the y values switch signs. Between negative 1 and 0, they switch signs. So we could say between x equals negative 1 and x equals 0. And then if we look again, we're negative, and then it goes back to positive between 1 and 2. So x equals 1 and x equals 2. So that's the intermediate value. It's basically saying that if the y values change and the function is a continuous function, you had to have crossed the x-axis and have a 0. And that is it for today.